Hi and Assalamualaikum. My name is Nur Shakira Natasha binti Muhammad Nawawi and I'm studying at UiT and Shah Alam in Mechanical Engineering. My ID number is 2020878616 and my class is EMD2 and 5A1. Today we are going to do one sample practice problem 3.3 for thermodynamics subject in chapter 3, which is First law of thermodynamics, part 4, energy balance for a steady flow system. Let's proceed to the question. Practice problem 3.3, question 8. Let's reread the question together and properly. Steam flows steadily through an adiabatic turbine. The inlet condition of the steam are 4 megapascal, 500 degrees Celsius and 80 meter per second, and the exit condition are 30 kilopascal, 92% quantity and 50 meter per second. The mass flow rate of the steam is 12 kg per second. Determine A, the change in kinetic energy, B, the power output, and C, the turbine inlet area. After we read the question, we need to list down all the data given for us. Firstly, this question is about steam. So we know that for the substance, our substance is water. Next, the inlet condition. The inlet condition, we can consider it as a state 1. So for the data given is for pressure 4 megapascal that equal to 4000 kilopascal, temperature T1 equal to 500 degrees Celsius and velocity equal to 80 meter per second. Next, for exit condition that we consider as a state 2. For pressure is equal to 30 kilopascal. For quality is 92%. Equal to 0.92, and the velocity is 50 meter per second. And the last one is the mass flow rate is 12 kg per second. Before we consider to answer the question, this question is all about the adiabatic turbine. Next, for solution. For the data given, we can find the phase of the state 1 and state 2 to get another data that we can use to find the change in kinetic energy, the power output, and the turbine inlet area. Okay, state 1, to find its phase, it provides us the value of pressure and temperature. So we can use a TV diagram. Here, we can see that the temperature given is more than the temperature saturated at 4000 kilopascal. That means its phase is superheated. Next, the V also more than the VG. To get the other value, we can use the superheated table, which is table A6, and we get the V1 is equal to 0.0864 meter cube per kg, and H1 is 3446.0 kilojoule per kg. Next, state 2. For state 2, we already know the phase is mixture. It is because for the question, it's already give us the value for quality, which is quality equal to 92%. So to find another data, we can use the table of saturated water, which is table A5, to get the value of HF, HG, and HFG. For HF, we got 289.27 kJ per kg. For HG, we got 2624.6 kJ per kg. And the last one is HFG equal to 2335.3 kJ per kg. To find the value of H, we need to use the equation of mixture, which is H equal to HF plus X multiplied with HFG. So we use this value and substitute into the equation, and we got the value of H equal to 2437.746 kilojoule per kg. So now, after we got all the data, we can proceed for question A, which is we need to find the change in kinetic energy. To find the change in kinetic energy, we can use this formula. Delta KE equal to velocity state 2 power 2 minus with velocity state 1 power 2 over with 2000. Then we substitute the value of velocity state 2, which is 50 meter per second power 2 minus with velocity state 1, 80 meter per second power 2 over with 2000. The answer for this question I got negative 1.95 kJ per kg. Next question is, we need to find the power output. For power output, we need to use the energy balance equation, which is E dot in is equal to E dot out. After we summarize this equation, we got that W dot out is equal to M dot multiplied with H1 minus H2 plus with velocity state 1 power 2 minus with velocity state 2 power 2 over with 2000. And we substitute the data into this equation. For the answer, I got 12,122.448 kilowatt. But for this answer, we can simplify to megawatt, which is 12.1 megawatt. Next, for the last question is, we need to find the turbine inlet area. To find the turbine inlet area, we can use formula m dot equal to rho AV. Rho is a density, A is area, V is a velocity. For this question, we don't have any value of density, but we know that density is equal to 1 over specific volume. So we can change the density with 1 over specific volume and simplify the equation. After that, we substitute the data into this equation and we got the answer is 0.013 meter square. That's all from me. Thank you for everyone that watching my video and stay safe.